factorise as far as possible x cubed minus x squared minus x minus 2. So let f of x be equal to x cubed minus x squared minus x minus 2. Let's try f of 1 to start with. So that gives me 1, take away 1, take away 1, take away 2. And we don't need to worry about what that is. It just clearly isn't 0, so it doesn't help us. Let's try f of negative 1. So that's going to be negative 1, take away 1, add 1, take away 2. Once again, that clearly isn't 0. Let's try f of 2. So that's 8 take away 4, take away 2, take away 2. Now that one is 0, so that tells me that x minus 2 is a factor. And so I can say that x cubed minus x squared minus x minus 2 is x minus 2 multiplied by some quadratic. Now clearly this needs to be x squared so that when we expand out we get a single x cubed, and clearly if that's negative 2 and this one's negative 2, we need a plus 1 in this end of the bracket, and then we'll work out what we need in the middle. So if we think about getting the negative x squared term, where would the x squareds come from over here? Well, we'd have this, and this one will give us an x squared as well. So that's going to be negative 2x squared plus ax squared. Bring this over, and that gives me x squared is equal to ax squared, so a must be equal to 1. So now we have x minus 2 x squared plus x plus 1, and I can't see any obvious factors of that, and in fact if we investigate that using the discriminant, we can see that that's 1 take away 4 times 1 times 1, which is negative 3, and so clearly this doesn't intersect the axis and it won't factorise. We can't find any roots of this quadratic. So that's as far as we can go with this one.